concepts of Section 5 of Module 4, Operations of Radical Expressions. So these are kind of the properties of radicals. So we have the product property. So as long as what's inside the radical is being multiplied, then we can separate that into two different radicals with the same index, so same type of root, and we can separate those products. So for instance, I could take square root of 36 and separate that into square root of 3 times the square root of 4, or sorry, square root of 3 times square root of 12, or I could even multiply them. I can go this way, take two square roots and multiply them. So I can multiply roots when they're the same type of root. So both cube roots or both fourth roots, I can multiply their radicands, what's inside the radical sign, okay? And I also could separate them too. And then also when I'm dividing, I can separate those into two as well. That's the same index. Okay, so anytime I take the root of a fraction, I can separate that to the root of the top over the root of the bottom. Okay, and just whatever index that is, these become the same index. So A over B. Okay, so that's kind of the idea behind simplifying. Well, how far do you simplify? Well, these are kind of the general rules of simplifying. How far do you go? Well, you keep going until you have the smallest possible index. Okay. Also, when the radicand contains no factor, so if I have the square root of 8, I want to reduce that down to 2 root 2, right? And whatever power. So if it was the cube root, say of cube root of say 16, I would want to reduce that down to 2 root 3, 2 cube root of 2, because 2 cubed would be 8. 8 times 2 is 16, right? So I break it down, look for groups of 3. Okay, so basically simplifying radicals. And then no fraction. So anytime I have something to a fraction, a root of something to a fraction, I want to break that down and get rid of the fraction. Take the nth root of the top, just like we talked about, over the nth root of the bottom, and then break that down so we have no radicals. That's what it's called in rationalizing the denominator, which we'll do in these examples, where no radicals are in the bottom. So we want to rationalize this. And so that's kind of the concepts of simplifying radical expressions and how we can take square roots and cube roots and simplify them down and separate them by multiplication and division.